numbers, right, anything that can be written as a fraction, which is nearly all numbers, okay, right, or, I'll explain what R is in a minute, right, R less Q are the irrational numbers. So irrational numbers don't have their own letter at all, right, okay, so someone deemed them not important enough to get their own letter. So an irrational number is a number that cannot be written as a fraction, as in a decimal that goes on forever, right? Not a recurring decimal now, right? You know, 1/3 can be written as a fraction, and that's 0.33333. If it's a recurring decimal, it can be written as a fraction. But if it's something like pi, 3.14, I don't know what it goes after that, but right, okay, it's not recurring, there's no pattern, it's just random numbers, right, and it goes on forever. Right, that number e we came across is also an irrational number. The square root of 2 is an irrational number. It's 1 point whatever and it goes on forever. And it's not a recurring decimal, as in there's no pattern to the numbers after the point. Right, okay, so irrational numbers. And finally, R are real numbers, everything. So R is real numbers. Right, why am I revising this? Because we're going to come up with a new set of numbers there in a minute. Right, okay? Well, we're not going to come up with it, we're going to learn about it. Right, okay? So just on a set, okay? Right, if I had a set, girls, in the middle I have natural numbers. Right, then around that I would have Z. Right, as in all natural numbers are also integers. Right, you know that, don't you? Right, okay, around that I would have Q. Right, as in irrational numbers. Right, okay, so all natural numbers and integers are also irrational numbers. They can all be written as fractions. Put them over 1, they're a fraction. Right, okay, and finally around the outside I have the real numbers. So everything is real. Right, so everything is real, right, okay, all rational numbers are integers and natural numbers, all integers are natural numbers, and natural numbers are nothing else, or sorry, natural numbers are everything. Natural numbers are in the Z set, they're in the Q set, and they're in the R set. Okay, is that alright? Okay, that's the first section. Now there's constructing root 2, I'm going to leave that until 6th year. Right, it's not very hard, but I just don't want to do it now. Right, now I'm going to talk about imaginary numbers. Right, okay, so imaginary numbers. So imaginary numbers is what we're on to today. Right, it sounds very complicated. Right, okay, but it's not. Right, okay, just bear with me a minute, okay, before I write anything down. Right, if you get the square, try to get the square root of -9. Right, if you try to get, does anyone know what the square root of -9 is? No, and if you do it in a calculator, it doesn't exist. As in, no number squared will give you -9, because -3 squared is +9, isn't it? So the square root of -9 doesn't exist. Right, and we had this already when we were deciding whether the roots of an equation were real or imaginary or equal. Remember we did the b squared minus 4ac. Right, okay, so the square root of -9 doesn't exist. Right, the square root of -16 doesn't exist. So basically you can't get the square root of a negative number. But as we've seen, it does come up in maths. Right, okay, so they had to come up with a way to deal with it. Right, okay, so that's how they introduced this whole set of imaginary numbers. So this is what imaginary numbers is, that the square root of -1 is represented by the letter I. And guess what I is? I is imaginary. Okay, so the square root of -1 is represented by the letter I. So what we have, if we have the square root of -9, that can be written as the square root of 9 multiplied by the square root of -1. right? So the square root of 9 is, what is the square root of 9? 3. And the square root of minus 1, I write that as I. So the square root of minus 9 can be written as 3i, right? Is that okay? So you can jot it down now, right? Square root of minus 16, again, doesn't exist, but I can write that as, that's the square root of 16 multiplied by the square root of minus 1, right, which is 4i. So square root of minus 1, you never write the square root of minus 1, you write I. Okay? Right. Okay. Can I go? Right. So numbers such as minus 1 plus I, 3 minus 2I, minus 4 plus 7i. These are called complex numbers. So a complex number has a real part and an imaginary part. Okay, so we just learned what imaginary numbers are, right? Okay, so a complex number has a real part and an imaginary part. So a complex number has a real part So for example, minus 1 plus I, minus 1 is the real part, plus I is the imaginary part. 3 is the real part, minus 2I is the imaginary part, right? Whatever that was, what did I write? Minus 4 is the real part, 7I is the imaginary part, right? The imaginary part is pretty obvious because it's got an I in it, okay? Got it? Complex numbers, right? Okay? And the set of complex numbers, you know, we'd N for natural numbers, we had Z for integers, Q for rational numbers, R for real numbers. The set of complex numbers, girls, is C. And C goes around the outside again, right? So you know the way the last circle we had was R? C goes around the outside again, because every real number can be written as a complex number, as in the number 2 can be written 2 plus 0i, so it's a complex number, isn't it? Right? All numbers can be written as complex numbers if you just put a 0i onto the end of them. So all numbers are complex numbers, right? Okay, but the imaginary numbers would be on the outside, right? Okay, is that okay? Right. How are we going to deal with this? We're going to solve the equation. So example 1. Solve right? So solve x squared plus 9 equals 0. Right, it's not the difference of two squares. If it was the difference of two squares, we could factorize it, let each bracket equal to 0, right? Okay, but you can't factorize. So what we have to do is we have to go x squared is equal to minus 9 when it comes across, right? So that means x is equal to the square root of minus 9, right? which is equal to the square root of 9 times the square root of minus 1. Agreed? Now the square root of 9, what I didn't say a minute ago was the square root of 9 can be plus or minus 3, can't it? So the square root of 9 can be plus 3, 3 squared is 9, can be minus 3 by minus 3 is also 9. Right, so it can be plus or minus 3, and I write the square root of minus 1 as I. So my answer is solve, x is plus or minus 3i. Okay, so what I didn't say up at the top was the plus or minus thing. Okay. You all with me? Can I move it up? Everyone okay? So example 2. Solve. Let's see, is there any solves there? Yeah. X squared minus 2x plus 17 equals 0. So normally I'd factorize, right? You're not going to be able to find factors, so what have I to use? If you can't find factors, what do I use? The minus b formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2 times a. So a is 1, b is minus 2, c equals 17. Okay? So it's minus 2 plus minus the square root of b to b squared is minus 2 to b squared minus 4 times a is 1, c is 17 all over 2 times a, which is 2 times 1. Now, be careful with this. You can't put the whole lot into the calculator because an error message will come up, because guess what? You're going to be getting the square root of a negative number, right? So you know the way if you were doing the minus b formula in algebra, you'd stick the whole lot into the calculator, press equals, job done, right? If you put the whole lot into the calculator and press equals, it's going to give you an error message because you're going to be trying to get the square root of a negative number, which doesn't exist. So what you need to do is you need to do the bit under the bracket out, or under the square root sign, out separately. So it's minus 2 is plus 2, plus minus. Don't put in the square root sign, because if you put in the square root sign and then the sum, it will give you an error message. Just put in open bracket minus 2 squared minus 4 bracket 1 bracket 17. Okay, and that will give you minus 64 all over 2. Is that right? So that would be, I can write that as 2 plus or minus the square root of minus 64 doesn't exist. I can write it as 64 and multiply by the square root of minus 1 all over 2. Okay? Next line, that's 2 plus or minus the square root of 64 is 8. I write, and the plus or minus is already in there, so you don't need to do plus or minus 8, right, because it's already in there. Square root of minus 1 is written as I divided by 2, so that means divide each term by 2, so 2 divided by 2 is 1, and 8i divided by 2 is 4i. So your answer is 1 plus 4i and 1 minus 4i. Is that okay? Are we good? Can I go? Right. I want to add or subtract complex numbers. Adding or subtract, adding. add or subtract the real and imaginary parts separately. It's like adding x's and y's. Right, so for example, if you had 4 plus 3i plus 1 minus 2i, 1 minus I, okay, that would get rid of the brackets. There's a plus in the middle, so there's no change, so it'd be minus 2 minus I. And you do put the real bits together, so it's 4, take away 2 is 2, and 3i minus I is plus 2i. There's your answer. Right, add the real bits and the imaginary bits. Not a lot to that, is there? Algebra, x's and y's, real, imaginary, friend. Okay, right, if we had just a subtraction one, so let's put example 1, sorry, example 1, example 2. If we have 2 minus 3i minus 3 plus 4i. Is that okay? So just be careful of the minus in the middle. When you're minusing them, you have to change all the signs in the second bracket. So that's 2 minus 3i minus 3 minus 4i, and that would be minus 1 minus 7i. We're all good with that, I presume? Right? Yeah? Am I going for time? Holds. Right, multiplying, we're all fine, are we? Yeah, nothing hard so far. Don't worry, it'll come. Right, multiplying complex numbers is next. So remember, I is equal to the square root of minus 1. What would I squared be? What would I squared be? If I is the square root of minus 1, what would I squared be? Minus 1, wouldn't it? If you square that, square that, you'll get I squared. Square this, you'll just get minus 1. Agreed? Right? So never replace I. So if you have an I in the equation, like we did up there, never replace it with the square root of minus 1. There's no point. Never replace I. Always replace I squared. So the minute you see an I squared, you replace it with minus 1. Right? So when we're multiplying complex numbers, an I squared is going to pop up, right? You always replace it with minus 1. Never ever replace I, because there's no benefit, right? But replacing I squared with minus 1 will simplify things for you, right? So for example 1, if I asked you to multiply 2 plus 3i multiplied by 1 plus, no, I do minus 1 minus 2i. Is that okay? Right, multiply. So we need to, same as algebra, split up the first bracket, write second bracket down twice. So that's 2 times 1 minus 2i plus 3i times 1 minus 2i. I'll just give you a minute to write that down so I can move it up. Will I go? Can I go? We're all okay? Multiplying out, that's 2 minus 4i plus 3i minus 6i squared. Is that okay? The minute you see an I squared, replace it with minus 1, right? So that's 2 minus 4i, never replace the i's, right? Plus 3i, and it's minus 6 times minus 1. Okay, so that's 2 minus 4i plus 3i plus 6, minus by minus is plus, 6 by 1 is 6. So 6i squared is actually plus 6. Sorry, minus 6i squared is plus 6. Right, put the real bits together. 2 plus 6 is 8. Put the imaginary bits together is minus 4 plus 3 is minus 1i, which is just minus I. That's your answer. Is that okay? Multiplying, is it fine? Do we need another example? Pretty much okay. Right, are we? Right, okay. So what I'm going to do is I'm going to ask you to do page 8. Right. So as I say, girls, it's book 5. Right. Page 8. Let's do 1 to 7. All the part 2s, so only the part 2s, right? So 1 part 2, 2 part 2, 3 part 2, right, etc. Right, let's do number 8, and let's have a go at number 9, okay? Is that alright? So 1 to 7, only the part 2s, not the whole lot of them. Now you'll be there for a year, right? So only the part 2s, all of number 8, all of number 9.